Here's the challenge that we have. We don't yet have the technological breakthroughs that can completely replace fossil fuels.
Oh, really?
Unless somebody here invents something tomorrow, which would be very helpful. And if you have it, let me know. We'll get it going right away. But
Mr. President, the U.S. Navy should have already briefed you on their recent alpha scanning detection of tritium byproducts produced by SPA-WAR, the U.S. Navy's Cold Fusion Research Center. We have direct evidence of low-level nuclear reactions occurring in laboratories all over the world. Now all we need is the physics and the theory to get it to work right consistently. Mr. President, I have it, and now I am letting you know, so you can get it going right away. I think you said it best.
we can't drill our way out of the problem. That's why we've got to get moving on this clean energy. It's one of my highest priorities, and I think it's got to be one of our highest strategic priorities as an economy. It has the potential of being an enormous growth industry.
Oh, you ain't kidding. This is a revolution that has been long overdue. Cold fusion has been like a genie, shrugging at all of our scientists who haven't figured out that he only appears when you rub the lamp, and he doesn't appear unless you rub the lamp. The only problem is that the cold fusion reaction is a bit more complicated than rubbing a lamp. For one, it only seems to occur at or around the 50 nanometer dimension, meaning that precision nanotechnology will be needed to produce working reactors. Defective palladium cathodes created a wave of experimental skepticism when laboratories found that they could not reproduce the reaction. This was due to impurities within the metal, which changed the lattice structure and thus shifted the dimensions of the lattice. The stimulation frequency was also a key factor in catalyzing the reaction. But more importantly, understanding the relation between the 50 nanometer dimension and the 14 megahertz stimulation frequency. And that's where physics has come to the rescue. In the book, What is Quantum Mechanics by the Lex Foundation, a team of scientists explain the deepest mysteries in quantum physics, namely the fine structure constant and the velocity of the quantum transition. These scientists explain that if the velocity of the quantum transition were known, it would solve all kinds of problems in modern quantum theory. They were correct. This velocity of quantum transition was revealed to us in the last place that the theoretical physicists were seriously considering. The key to cold fusion is artificially stimulating atoms into a state of artificially induced quantum transition, while squeezing them tightly together within the confines of a 50 nanometer lattice structure. While stimulating these atoms at their resonant atomic velocity of 1,094,000 meters per second, or 2 over 137 times the speed of light, the strong nuclear fields which bind the atom slip out of alignment, thinking they are absorbing a photon, but instead two nuclei are absorbed into one, and fusion proceeds. Cold fusion is here. The Coulomb barrier is much easier to break by outsmarting the atom than trying to strong-arm it by brute force like the hot fusion scientists have been trying and failing at for years. Trillions of dollars have been sunk into hot fusion research, and hot fusion scientists have been eager to hold on to that kind of funding. It's time to give cold fusion another chance and revisit the Copenhagen interpretation of quantum mechanics that Einstein never agreed with, but could never find the math to prove otherwise. If only Einstein were alive today, the theory that Frank Synardzik came up with provides such a stunning unification of quantum mechanics and special relativity that the theory could stand alone without the decades of cold fusion anomalies and positive test results staring us in the face, leading us to discover the velocity of the quantum transition and the true nature by which light interacts with atoms. In fact, anomalous low-temperature fusion reactions have been reported since 1927, when Swedish scientist J. Tandberg stated that he had fused hydrogen into helium in an electrolytic cell with palladium electrodes. There's even evidence of low-level nuclear reactions in the geological record. Please check the links in the description of this video or visit coldfusionnow.org for a more thorough review on the mounting experimental and theoretical science to support cold fusion. Dr. Peter Hagelstein estimated that $10 million distributed to various groups working in this field would be enough to take it to the next level. If you are interested in funding research that could solve some of the biggest problems on our planet, there are many opportunities to be part of this exciting new discovery. If you are a cold fusion researcher or scientist, please contact us. We'll help to get your story told, If you are an activist and would like cold fusion literature, or a student who wants something serious to show your professor, please visit the website or check the links in the description below. For a technical and up-to-date scientific text on cold fusion, I highly recommend Dr. Edmund Storm's book, Science of Low-Energy Nuclear Reaction, and absolutely check out the work of a guy named Frank Znaidarczyk, and try plugging Znaidarczyk's constant into Wolfram Alpha to see what happens. The remainder of this video is an adaptation from Dr. Eugene Malov's book, Fire from Ice, Searching for the Truth Behind the Cold Fusion Furor. This is quite possibly the best book that you can buy for a basic introduction to cold fusion. Gene Malov was an MIT scientist who was found murdered on May 14, 2004 in Norwich, Connecticut, while cleaning a recently vacated rental property owned by his parents, the home he grew up in. Although police investigators chalk it up to a botched robbery attempt, no one has yet been convicted of the murder, one of the many still unsolved mysteries in the cold fusion drama. Skeptics have written 100 obituaries for cold fusion, the unprecedented miracle or mistake that burst out of Utah into the public arena on March 23, 1989. But despite many unanswered questions about what cold fusion is or is not, evidence for the phenomenon, or phenomena, is now much too compelling to dismiss. Some would call the scientific clues only provocative. I choose to say compelling. With an electrical power supply hooked up to palladium and platinum electrodes dipped in a jar of heavy water spiked with special lithium salt, chemists Martin Fleischmann and B. Stanley Pons were thought to have unleashed one of the wildest goose chases in scientific history. Now there is a significant possibility that they have discovered a quite revolutionary phenomenon that, along with hot fusion, could conceivably turn the world's oceans into bottomless fuel tanks. Cold fusion is very likely to be real after all. Despite many roadblocks that arose against confirming it as a new physical phenomenon, it is now here to stay. For a time, negative experiments and widespread skepticism seem to have put cold fusion permanently on ice. Incredulity still runs deep. But cold fusion research is now very much alive in laboratories far and wide. It moves forward through those scientists with intense curiosity and courage to pursue these studies in face of mountains of ridicule. There is no chance whatsoever that cold fusion is a mistake. There is exceedingly remote possibility that cold fusion is a collection of many mistakes made in nuclear measurements of many different kinds, in heat measurements of great variety, and in all manner of controlled experiments. But to believe that hundreds of scientists around the world have made scores of systematic mistakes about the nuclear and the nuclear seeming anomalies that they have reported is to stretch credulity to the breaking point. To distort the meaning of scientific evidence to absurd limits. Cold fusion is not pathological science, as many have charged, but for critics to continue to describe it as such, or to ignore it, is completely pathological. Current evidence suggests that nuclear processes are actually at work in what first seemed to be merely tabletop chemical experiments. This is absolutely shocking, and the root of widespread disbelief in cold fusion among scientists. It is really quite amazing by what margins competent but conservative scientists and engineers can miss the mark when they start with the preconceived idea that what they are investigating is impossible. When this happens, the most well-informed men become blinded by their prejudices and are unable to see what lies directly ahead of them. Arthur C. Clarke, Profiles of the Future. Cold fusion phenomena are now seen in very dissimilar but related physical systems: pressurized gas cells, electrochemical cells with molten metal salts, and metal chips and films alloyed with fusion fuel. To an extent, the phenomenon has remained not repeatable at will, but repeatable, to be sure, in a statistical sense, and sometimes now with very high confidence. The same has been true in the early development of certain solid-state electronic devices as well, don't forget. The measurement of power in the form of heat coming from some cold fusion cells is extraordinarily impressive, tens to over 1,000 times the energy that could emerge from any conceivable chemical reaction. If the numbers from some experiments are to be believed, they add up to tens and even hundreds of kilowatt-hours coming from each cubic centimeter of cold fusion cell electrode material, about the volume of a stack of 2 pennies. You know what a kilowatt-hour of electricity is when you pay for 10 100-watt light bulbs turned on for 1 hour. Or more vividly, a kilowatt-hour is the energy of motion in a 4,000-pound car traveling at 140 miles. A 1 megawatt coal-fired power plant uses about 20,000 rail cars of coal per year to run it. A 1 megawatt cold fusion power plant would only require half a ton of heavy water per year. Furthermore, and most important, there is now a theoretical basis to begin to understand these apparent cold fusion phenomena. Through a sometimes tortured, contentious process, the truth ultimately triumphs in science. This is scientific research done in the real world, not by idealized textbook prescriptions. Science is not conducted by pull, nor by appeal to authority or public opinion, nor always shackled to an imperfect and occasionally obstructive peer review process. Science proceeds through dogged, experimental, and theoretical effort. Now that many more facts are available, and the furor has quieted down, the cold fusion drama can be revisited in its delicious and delirious detail. The story of cold fusion is a human drama. There were fights to publish and to forestall publication, issues of priority of discovery, funding matters, misinformation and disinformation, rumors that became fact, questions of academic standing, and even allegations of scientific deceit. The hard lessons in science learned in the quest for cold fusion will depend on the ultimate resolution of the scientific questions. But whatever the outcome, some things are already quite clear. Number 1. Spectacular resistance to paradigm shifts in science are alive and well. Plasma fusion physicists were extremely reluctant to consider new fusion mechanisms, even though they knew very well that the environments of electrochemical cells and palladium metal atomic lattices were remarkably different from the high-temperature gaseous systems to which they were accustomed. Number 2. Majority does not rule in science. It is a gross mistake to draw conclusions about the validity of reported findings by polling the membership of this or the other scientific organization or panel. Number 3. Irving Langmuir's rules for identifying so-called pathological science are best retired to the junk heap for prejudice and name-calling. Number 4. Occam's razor is too easily forgotten. In science, the simplest unifying theory or connection is often the most appropriate. Better to have a single explanation to bridge a host of apparently related phenomena than to concoct Baroque excuses for why multiple independent experiments may all be systematically incorrect. Any possible nuclear effect, even a tiny suspected one, such as low levels of neutron particle emissions, seemingly unconnected with the heat production, should have been a tip-off that other puzzling and erratic effects in similar physical systems might also have something to do with nuclear phenomena. Number 5. Use extreme caution in dismissing experimental results just because theory suggests that they are impossible. Theory must guide science, but it should not be allowed to take the driver's seat, especially when exploring the frontier. Number 6. The fear that possible scientific error would be ridiculed, or worse, interpreted as fraud, is stultifying. A witch hunt against cold fusion affected researchers. Some who wanted to work in the field did not get involved for fear of scorn. Others hid positive results from colleagues, anticipating career problems. And some laboratory managers refused to allow technical papers to be published on positive results obtained in their organizations. Most incredibly, some scientists publicly decried cold fusion while privately supporting its research. Number 7. The peer review process by which articles make their way into journals is not infallible. While peer review is meant to act as a filter against spurious results and sloppy science, mismanaged or unchecked, it can be a tyrannical obstacle to progress as well. It is unwise to be persuaded by the editorial position and selection of technical articles that appear in a single well-respected publication. And finally, number 8, vested scientific interests are not easily persuaded to share their resources. Too small a total funding pie, in this case limited federal expenditures for energy research, led naturally to rivalry and anti-scientific tendencies that would have moderated with a policy of broader research support. The hot fusion fraternity, like any scientific community with its back to the wall, may find it difficult to draw impartial conclusions about a perceived threat to its dominance. And if you want more, you'll have to read the book. This video is dedicated to Dr. Eugene Maloff and the future of cold fusion research and development as a viable source of alternative energy. The cold fusion revolution is alive and well, resurrected from its grave and ready to make a comeback. But we can't do it alone. We need your help. Send this video out to as many people as you can. Help us get the word out there. Give cold fusion the chance it needs to prove itself, and I promise you won't be disappointed this time. The science is real, and to ignore the mountains of evidence in front of us is to gamble away the promise of a clean energy future that might have already happened if it weren't for attitudes and ignorance. Thank you.